Hello everyone. So this is a question from NEET 2025. Given below are two statements. Statement 1. Ferromagnetism is considered as an extreme form of paramagnetism. Okay. And we have one more statement. The number of unpaired electrons in a Cr plus 2 ion, atomic number 24, is the same as that of a Nd plus 3 neodymium ion. Z is equal to 60. Okay, so we have to determine whether they are true or false. The chapters involved is D and F block and solid state. Okay, so talking about statement one first. So it talks about ferromagnetism and paramagnetism. Okay, so magnetic properties of different materials are due to magnetic moments that arise due to orbital motion and spinning motion of the electron. Very important. Okay, so magnetic properties are due to magnetic moment, which is represented by mu, and it arises due to orbital motion and spinning motion of the electron. Okay, so we will look into them one by one. Orbital motion leads to magnetic moment, and spinning motion also leads to magnetic moment. Okay, so let's say that this is the nucleus and this is the electron, which is revolving around the nucleus. So because of this revolution of electron around the nucleus, it leads to orbital magnetic moment whose direction is this. And so this is because of the orbital motion. And also the electron also spins or rotates, that leads to spin magnetic moment. Okay, so the electron also spins on its own axis. So let's say this is the direction of spin. So the spin magnetic moment will have a direction this. So this is the spin magnetic moment, and this is the orbital magnetic moment. So the revolution of electron and also the rotation of electron leads to the orbital magnetic moment and spin magnetic moment. Therefore, each electron may be considered as a small magnet having a permanent magnetic moment. Okay, so based on behavior in the external magnetic field, very important. Based on behavior in the presence of external magnetic field, the substances are divided into different categories. The first category is paramagnetic substances. Okay, so substances which are attracted by the external magnetic field. So these guys are attracted by the external magnetic field. Okay, and this property is shown by those substances whose atoms, ions, or molecules contain unpaired electron. Very important. So they should contain unpaired electron. Examples, we have Cu plus 2, Fe plus 3, and Cr plus 3. Cu plus 2, Fe plus 3, and Cr plus 3. Okay, but these substances, they lose their magnetism in absence of external magnetic field. Very important. These guys, they lose their magnetism in absence of external magnetic field. The next category of substances is ferromagnetic substances. Okay, so those substances that show permanent magnetism even in the absence of external magnetic field. So these guys show permanent magnetism even in the absence of external magnetic field. We have examples is iron, nickel, cobalt. Okay, and such substances, they remain permanently magnetized once they have been magnetized. Very important. That's how they are different from paramagnetic substances. They remain permanently magnetized once they have been magnetized. And these substances are very strongly attracted by a magnetic field. Okay, the reason for such behavior is that in the solid state, metal ions of these substances are grouped together into small regions called domains. Okay, so there is something called domains, and each domain act as a tiny magnet having a definite magnetic moment. Okay, to understand this, let us say this is the substance, and I will draw a diagram to explain. So few ions, they group together in small regions, and these are called domains. So this is one domain, this is another domain, this is another domain, and each domain will act as a tiny magnet having a definite magnetic moment. Okay, so each domain will have a definite magnetic moment. Now, in an unmagnetized piece of any ferromagnetic substance, let's say it has not been magnetized, domains are randomly oriented such that their magnetic moments cancel each other. So these guys are randomly oriented. So these are, these arrows are the direction of the overall magnetic moment in these particular regions. So in the absence of magnetic field, when there is no magnetic field, they are randomly oriented in random directions. And because of this random orientation, their magnetic moments, so all of them, they cancel each other. Okay, but when the substance is placed in an external magnetic field, all the domains get oriented in the direction of the magnetic field. Very important. Okay, when the substance is placed in a magnetic field, all the domains get oriented in the direction of the magnetic field. So therefore, if we remove these um, directions, so this was in the absence of a magnetic field. In the presence, it will look something like this. Let's say the external magnetic field is like this. So every domain will have this orientation of the magnetic moment, of their individual magnetic moment. As a result, the substance has a very high magnetic moment, since all of them in all the domains are aligned in a particular directions, and this ordering of domain remains even when you remove this external magnetic field. So the substance remain permanently magnetized. So therefore, ferromagnetism is a case of large or extreme amount of paramagnetism. So therefore, statement 1 is correct. Okay, statement 1 says that Ferromagnetism is considered as an extreme form of paramagnetism. Yes, it's a correct statement. Next, we have statement 2. The number of unpaired electrons in a Cr plus 2 ion is the same as that of a Nd plus 3 ion. Okay, so let's talk about statement 2. So the electronic configuration of chromium is argon core 3d5 4s1. For Cr plus 2, we have to remove 2 electrons. So one will be removed from 4s and one from 3d. So therefore the configuration of Cr plus 2 is going to be argon core and 3d4, right? So therefore Cr plus 2 has 4 unpaired electrons. Cool. Then we have to talk about neodymium. Its atomic number is 60. Okay, so we should know that lanthanoids, that is the filling of 4f, starts after lanthanum. Okay, lanthanum is having the atomic number 57. Its configuration is xenon core 5d1 6s2, and after lanthanum, lanthanoid starts, or the filling of 4f start. So after lanthanum we have cerium. So cerium is Z is equal to 58 atomic number. So configuration will be xenon core 4f1 5d1 6s2. After that we have praseodymium. The atomic number is 59 and its configuration is Xe 4f3 6s2. Very important. It is not 4f2 5d1 6s2. Okay, be careful. It is 4f3 6s2. And then we have our guy, that is neodymium. So this is how you are expected to know the configuration of neodymium. So atomic number is 60 and configuration is xenon core 4f4 6s2. For neodymium plus 3 ion, we have to remove 3 electrons. So 2 from 6s and 1 from 4f. So therefore the configuration of neodymium plus 3 is going to be xenon core and 4f3. So therefore, Nd plus 3 has 3 unpaired electron. So therefore statement 2 is false. Statement 2 says that the number of unpaired electrons in Cr plus 2 and Nd plus 3 is same. No, it is not same. So Nd plus 3 has 3 and Cr plus 2 has 4. Okay. So statement 2 is false. So therefore 1 is correct, 2 is false. Okay. Thank you.